I'm going to use Excel to take the output from my SaberBox and kind of look at it using graphs and cool features and just kind of walking through it. So first thing we need to do, need to find a Saber clip to analyze. So this is my SaberBox. Description down in the description below will give you some links to how you kind of set it up, and you can use it if you'd like. So the clip we're going to use is this one, kapow. So to take a quick look at the clip that we're going to look at, two fencers, fence, probably attack left. Looks like the right fencer pulls her arm a little bit. Okay, go back to the SaberBox, analyze. I'm going to run through the analysis of this. I'll probably fast forward this part because I imagine it gets a little tedious to sitting here and watching it go. So I expect it'll probably take about 5 minutes or so. Excellent, excellent. So now we have the clip downloaded and analyzed. Now before, at this point, we just go to the clip and watch it, make sure it makes sense. Your Google Drive that's connected to your the SaberBox, the first step that we did was we connected the two. And you look in under a whole bunch of folders, you eventually get the touches, left touch, which is where I store the link. And then the left touch vector clips acceleration. And this is a CSV file, comma, separated values. And it's 999 basically so that I know that it's the one that's associated with the link. I download it, boom, 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 download. And then we show in folder. And now you can open it. So you open up the file, the CSV file in Excel. The A column is going to be the acceleration of the left fencer. B is going to be the acceleration of the right fencer. And C and D just tells you the lights are on or off. 0 off, 1 on. And we're going to have, I think, 98 frames on this. Yep, 98 frames because it downloads 100. And then when it processes it to get the acceleration, you're going to lose 2 frames. So first thing I'm going to do is there's some processing that's normally done by the SaberBox. And one of the things it does is it doesn't look for any right of way after the lights turn on. And assumes the lights turn on together based on position of the bell guards. So everything after the lights turn on, I'm just going to get rid of. Whoop. Gone. Delete. And then I'm going to look at what the maximum value is. I'm going to do from, let's say, A1 to A67. And that just kind of gives you the idea of the max number here, so when I normalize it. So 4.2 times 10 to the first, so it's about 42 or 22. I'm going to say a max of 30. And I'm going to delete these C and D now because we know what these are. They're all lights are off. So I'm going to say this equals the minimum. Did I say maximum? I meant minimum. Of this number divided by 30 or 1. That way they'll be kind of put a ceiling of 30 for this value. And if it's higher than 30, it just reduces it down to 1. And if it is less than 30, then it divides by 30, and that kind of gets you the ceiling. It just makes the data look a little bit nicer. So now I'm going to Control D to fill down. Yes. I don't think, yep, because this bottom one's actually the max. We don't actually want to include that in the graph. And then I'll put some numbers over here just so I get the frames. So this will be 1. This will be this frame plus 1 just to get it to count down. Whoop. Come down here a bit. Fill down. And now I can take this and take that, and we can make a graph. Insert, charts, and this one looks pretty good. So to kind of look and see what we have here, let's see what the options we have here. Ooh. I like that. Good contrast. So here we have a chart, and we can take this and then we can compare this to the video that we just downloaded. So let's see here. I'll do some quick adjustments here. I know you're probably not interested in the semantics of this, but I'll do it quick. So this here is now our chart overlaid with the video. See this first section here, the first 10 frames? That's just for the on-guard positioning, everything's getting set up. And this first initial spike is basically just the position snapping into place. The Sabre box, it actually kind of ignores, just cuts off, so not kind of, totally actually does, cut off the first 15 frames. So that part doesn't even register, doesn't matter. And you can see here it's the positioning is kind of bouncing around, maybe a little camera motion, and right here, right around 47, 48, 49 or so, is when the fencers start moving. So we go back to our clip, whoop, go up, right around here is when, yep, they start moving. You can see they start moving forward, and then we can see they both start to attack. This blue is the fencer on the left, the orange is the fencer on the right, and you see the fencer on the right decelerates quickly, very strong deceleration right here. And so that's the acceleration of the hand, and that's right around early 60s, so maybe 63 or so. So we come back here. Nope, didn't mean to go quite that fast. So you see they both, come back just a little bit. They both come forward, and then fencer on the right, she pulls her hand a little bit, maybe not even moving backwards, just a strong deceleration, while the fencer on the left is accelerating forward. So look at that one more time, coming forward, pulls her hand, and then goes. And that pulling of the hand on the fencer right, for the right fencer, that's encapsulated by this right here. This dip in acceleration, which isn't even that much deceleration, it's not accelerating the way the left fencer is. And even though I don't actually know what the internals of the box are doing, because that's part of the AI machine learning process, this is kind of what I suspect that it's doing, and this is what I would look for. It's like, okay, you have a strong deceleration here. The left fencer had a strong acceleration finishing into the attack, and so they both started about the same time, and then the left fencer finished strong. And so that's why I would say this would be touch left. And so taking one more look at the clip again, that kind of makes sense. So I would say that makes sense for tack left. All right, so this is the next touch I want to look at. So two fencers come together, both prepare, and then I think I would probably call this right fencer goes first. So then running this through the Sabre box, we get a video that looks kind of like this. Yep, seems to track reasonably well. And then when we throw in the chart, we can see they're both pretty steady. Then they start moving around frame number 30. They both decelerate, and then it looks like the right fencer decelerates less, and then it starts accelerating again before the left fencer. And so after the two fencers stopped, the left fencer came forward again first. Now, does it still make a big difference or not? I don't know. My intuition is like, yeah, probably not. But if you look through this, so we say about frame 30, right there, and then they both stop around maybe frame 52, 53. So, yep, you can see they both stop. And then we said that the right fencer comes forward first. So looking at this, so you can see the left fencer, she pulled her hand down, and the right fencer, even though she stopped, she didn't pull her hand back as far, which makes sense why she's able to accelerate forward first. Now what's interesting here is it's actually tracking off the bell guard here. it's actually tracking her offhand. So I kind of wonder if you did like a, when you pulled your weapon hand, you kind of punch with your offhand. Wonder how that the saber box would deal with that. Not important, but it's kind of interesting. See where it would go. So that's why we have, so the left fencer pulling her hand back a lot, the right fencer pulling her hand back just a little, and therefore she's able to come forward first and seize priority there. So that is how I would call it, how I would see this. And that's why I think that this, based off this little section right there, is why she would have right of way. Now looking at what the box says, it says the percentage here is about 74%. I'll say 75. About 75% right, about 25% left. So mostly sure right, but could go either way. So I think that seems reasonable. I am happy with that. All right, one more example. So over here, I'm going to use this example. Now, initially, I thought this one was attack from the right. Just look at this one more time. Yep, I probably would have called that attack for the right. So looking at our chart here, we have our setup time right here. Again, makes sense. There's kind of some on-guard positioning, and then right around 69, 68 is when we would expect them to actually say ready fence. So we look at this, skip forward a little bit, and we just look through, and right around 68, right around here, expect them to say fence. Yep, looks like they probably said fence. And then what happens is, whoop, they both attack, and then it looks like now this isn't real correct terminology, but they both start their attack at about the same time, but the left fencer finishes first before the right fencer. And I'm going to kind of ignore this little dip down here. I'm going to just kind of round it up, but I'm basically looking at this peak right there. And so when we look at this, we said right around, I think it was 80. I better check again. And right around 82 to mid 80s is when their final attack starts, the final portion of their attack. And yeah, it looks like they both come together. So what's interesting here is the left fencer takes one step, but the right fencer takes two. So you look at the left fencer, one step lunge. You look at the right fencer, you have 1, 2, followed by a lunge. And it's interesting that their final lunge, when their back foot is planted, both happened at pretty much the same time. But you can see on the chart right over here, it looks like the left fencer was accelerating forward. So their hand doesn't exactly match up with the feet. And you can kind of see here with the right fencer, he dips his hand slightly before going in for the final extension. And the left fencer, he already had his hand down, and so he just goes straight up for the final extension. So, I don't know. I think this would probably be attack from the left. I think that's what the director called, so that's reasonable assurance that I'm not completely wrong. And it's interesting that the box would... I did not expect the chart to actually look like this. So, this, I would actually probably say, is attack from the left. And looking at what the box says, bum bum bum. So looking at what the saber box puts out, so predicted value, 99% left, 0% right, 0% simul. So the saber box is pretty confident that this is actually touch left. But the difference is pretty small, so it's interesting. Interesting that it picks out that. So that's how I look at this, using how you can take the data, the comma-separated values data, put it into an Excel spreadsheet, then make a graph, and how you can then relate that to what's going on the fencing strip. Hope that helped. See you next time.